And this is problem 3 of 5 for our grade 11 forces in one dimension section of the 5 questions you're responsible for. This one reads, a 55 kilogram box is moved with a net force of 28 newtons. The applied force necessary is 185 newtons. So remember that the applied force and the net force are in the same direction. If the net force said negative, then there'd be something pushing this box in the other direction, and that's not the case. So our applied force is right there. We have our net force, it's 28, and 55 kilograms is not a force, but from that we can calculate the force of gravity, or if we need it, the normal force. Okay. So as soon as you have mass, you know you can get force of gravity, and in our case, the normal force. So A, what is the force of friction? So there's where we start. So we're given net force, we're given acceleration, and the only other force in play, removing some of that kind of force from the applied force, is friction. So our net force, which is the sum of all forces acting in the same direction, the net force then equals the applied force, and the only other force present horizontally is the force of friction. Net force is 28, applied force is 185. They are both in the same direction, so they're both positive. Force of friction is what we're trying to figure out. Subtract the 185 from both sides, and our force of friction comes out to be negative 157. The negative is key there. I'll be looking for that. The negative tells me and communicates that is the opposite direction of the applied force, which is consistent with the concept that we're doing in class. B asks, what is the normal force? Well, for us, the normal force is going to be the force of gravity. Okay? And so that equals mass times the acceleration of gravity. The mass is 55. Acceleration of gravity 9.81 meters per second squared. If you want to put the units in there. So kilograms times meters per second squared gives us the Newton unit for force, and that comes out to be about 540 newtons. And last, calculate the coefficient of kinetic friction. So to figure out the coefficient of kinetic friction, there's only one formula that contains that value. It's this one. Force of friction equals coefficient times the normal force. In A and B, we calculated the force of friction and normal force respectively, so we're going to use those values. So you have to be really careful not to make a mistake calculating friction or normal force, or your coefficient is going to come out to be incorrect as well. So putting our values in, we always use the magnitude of the force of friction, so it's going to be positive 157, and the magnitude of the normal force, positive 540. That's going to give us 0.29 for our coefficient of kinetic friction.